Yes, dear friends, I am going to discuss and tell you the torque on current carrying loop in magnetic field. Actually, you might have thought, how does electric motor works? Electric motor, what is the principle of working of electric motor? You use electric motors. Your fan in the classroom rotates when we switch on the circuit, current start flowing and rotates. So what is the principle that is explained by this topic? Torque on current carrying loop in magnetic field. In figure 1 here, there is horizontal magnetic field B, horizontal field, and in this field a conducting loop PQRS carrying current I is suspended vertical like this. Field is horizontal. This is side PQ, this is RS and PS. Now you know when current flows clockwise, every current loop has a dipole moment which is normal to plane of loop. If this is a loop, may be circular, may be rectangular. If current is flowing clockwise, then M is normal to this and into. So here this is vector M. You know M of loop is I barabar equal to IA. Magnitude. Direction by this. The direction of M makes angle theta with magnetic field. Here field, this is M. So angle theta is between here, direction of dipole moment and magnetic field. So here this current loop, side PQ and RS remain perpendicular to magnetic field always, whatever the orientation is there. Whatever the orientation of this loop, this side PQRS always remain perpendicular, and the direction, this QR and PS may be perpendicular, may be parallel, or any other angle also. Here I have taken the stand when normal to the plane of loop, that is the direction of dipole moment, make angle theta with B. In figure 2, what I have shown, this side PQ being perpendicular to magnetic field, carrying current I and has length L. This is breadth B. This is also length L. Action force F equal to BIL. Magnitude होगा BIL. Direction from cross product rule, L cross B into away from me. I have shown like this. And on side RS, it is towards me. So I have written at minus L. This is plus L. Side QP carrying current this way, actions for vertical here. This is length, this is B, L cross B, upward, and it is downward. So forces F dash and minus F dash are equal and opposite in magnitude, but they act along the same line. Forces F dash and minus F dash are equal and opposite in magnitude, but has same line of action. And when two forces act along same line of action, they cancel each other and produce no torque. No torque will act on it. These two sides, PQ and RS, action force F and F dash, this is represented the breadth B here. This PQ point represents the side PQ and this represents side RS. Little descriptive simple to understand. Actually, force everywhere we take resultant of force F here, this way, and this is F dash, minus F dash. And you know, when two equal and opposite forces act on a body along different line of action in opposite direction, they produce a torque, and magnitude of torque equal to, magnitude of torque equal to product of magnitude of one force and perpendicular distance between their line of action. So here that torque will be X into L. But F is equal to BIL and X is equal to, from this figure, X is equal to B sin theta. This angle theta, this is 90, so this is 90 minus that, this is 90 minus theta, or 90 theta, into F BIL, F equal to BIL. ये हमें लिखना है बस. I have to dictate you, so I will keep on writing on board so that you will understand. Little lengthy, है ना? So please, in figure 1. In figure 1, a rectangular conducting loop PQRS carrying current I is suspended in a horizontal magnetic field B. Vertically suspended है ना, is suspended, तो horizontally suspended तो vertically होगी. Here magnetic dipole moment vector M of the loop makes angle theta with B. Now, in every orientation, of loop, sides PQ and RS always perpendicular to B. Hence, each side experiences a force whose magnitude is F equal to BIL. BIL is the magnitude force these forces have direction opposite to each other. So in figure it is vector f or it is minus f dash. Now forces on sides QR and PS have same magnitude and that F dash magnitude होगा. Actually these make angle theta, so you can say B into B sin theta. Now magnitude BI BIL sin theta ना. Sorry, message from BIB sin theta. If theta becomes 0, means they become parallel, then force 0. But being equal and opposite and acting along the same line, cancel each other. The forces on side QR and PS cancel each other because they are acting along same line like this. One upward, one downward, so net force 0. So forces on side PQ and RS being opposite and acting along different line of action produce torque. So forces acting on sides PQ and RS produce torque. Produce torque. In figure 2, this figure 2 here, X is the line, this step perpendicular distance between line of action of forces, and torque, is equal to, and we know torque produced equal to perpendicular distance between lines of action of forces multiplied by magnitude of force. Multiplied by magnitude of force, and therefore from figure 2 hence from figure 2 is equal to x into f, यानी कि b sin theta into BIL into B into sine theta. It is area of loop. Length into breadth is equal to area of this loop is rectangular is equal to BIA sine theta. So torque acting on the loop had magnitude tau is equal to BIA sine theta. If there are n turns in the loop, if loop has capital N turns, then tau is equal to NBIA sine theta. But dear student, remember theta here is the angle between M and B, or you can write it as tau is equal to NIA M or B sine theta. Equation 1, equation 2. Here what is M? M is equal to NIA, यानी कि मैग्नेटिक डायपोल मोमेंट, मैग्नेटिक डायपोल मोमेंट. Equation 2. So theta is angle between M and B. So torque produce rotatory motion. So coil starts rotating from this situation to this. M become parallel to B. Theta becomes 0. So torque becomes 0. And the torque becomes 0, then turning effect becomes 0. So coil should stop keeping itself perpendicular to B. But due to inertia, moment of inertia, it may continue to move. And as soon as it goes this side, direction of torque, actually now M is this, B is this, M cross B, direction get changed, so it goes back. And by making few oscillation about theta equal to 0 position, this coil will come to rest. I will discuss the further many things here in next video because it will become a longer. But I am telling you here when देखो tau equal to MB sin theta. Theta is angle between M and B. In vector form we can write M cross B. This is very important to learn. I am stressing again and again. Please learn vector product. According to vector product in this situation, M is this, B is this. M is here, B is this. So this is clockwise. And direction of torque will be at right angle to the plane containing M and B. Direction of this torque will be at right angle to the plane containing vector M and B. Here B is this way, M is this way. So plane containing M and B is a horizontal plane. So it will be normal to plane into the downward. So torque will be along the axis which is lying in the plane of loop. Here it is this, no? So the direction, this is M, this is B. So direction of torque will be at right angle to M and B. Are you getting my point? This is B here, this is M here. So plane from them will be a horizontal plane. So M will be at right angle, torque will be at right angle to M and B both. So M ये B इनके परपेंडिकुलर दोनों और ये क्या M cross B तो clockwise into downward. And hence this loop will rotate about an axis lying in its plane like this. ये है वो axis rotation here. about it cannot rotate around this like this, मतलब ऐसे नहीं घूम सकती। क्यों नहीं घूम सकती? कि m नॉर्मल टू प्लेन ऑफ लूप है, अगर ये घूमे तो एक्सिस रोटेशन भी यही होगी, डायरेक्ट टॉर्क भी यही होगी, और डायरेक्ट टॉर्क जो है एट राइट एंगल टू बी और m दोनों के परपेंडिकुलर है। तो वी कांट रोटेट एनी कोयल अराउंड इटसेल्फ, ऐसे नहीं घूम सकती है। ये या तो यूँ घूमेगी या फिर यूँ घूमेगी, डिपेंडिंग ऑन ओरिएंटेशन ऑफ m and b. This is very important here to understand direction of torque. There is a question in our book NCERT book which cannot be explained by us if we don't know what is the direction of torque. Torque is always at right angle to m and b and determined by using right hand screw rule. I will take the coming effects later on in the next video.